Today we are going to discuss theorem number 1.4, root 2 is irrational. So we are going to take a look as to how we can prove this theorem and what is the step-by-step approach in doing the same. So let's begin. Proof. Let us assume to the contrary that root 2 is rational. So we have to prove that root 2 is irrational, but we are going to start by assuming that root 2 is a rational number. So from this we will get that we can find integers r and s not equal to 0 such that root 2 is equal to r by s. Now we can basically find two numbers r and s so that we can write root 2 in the form of p by q where q is not equal to 0. So moving on, suppose r and s have a common factor other than 1. Then we divide by the common factor to get root 2 is equal to a by b where a and b are co-prime. So as you know, in the p by q form also p and q are co-prime. So here we have assumed that maybe r and s have a common factor other than 1. So we are going to divide so that we get the reduced form of the fraction and we get root 2 is equal to a by b where a and b are co-prime. That means a and b do not have any other factor common other than 1. So a and b might not be prime themselves, but the only common factor they have is 1. For example, 14 by 15. So 14 and 15 are not prime numbers, but the only factor that they have in common is 1. Moving on. So when we multiply b by root 2 and take it to the other side, we get the equation b root 2 is equal to a. So the next step is squaring on both sides and rearranging. We get 2b square is equal to a square. Therefore 2 divides a square. So now when we square the equation b root 2 is equal to a, we get 2b square is equal to a square. Now from this equation we can infer that 2 divides a square. Now by theorem number 1.3 it follows that 2 divides a. So let me just show you what theorem number 1.3 said. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. So here, since 2 divides a square and 2 is a prime number, this implies that 2 is also going to divide a. This is theorem number 1.3. Moving on, the next step is, so we can write a is equal to 2c for some integer c. Since a is divisible by 2, we can write it as a is equal to 2c where c is going to be some integer. So substituting for a, we get 2b square is equal to 4c square, that is b square is equal to 2c square. So when we substitute in the equation 2b square is equal to a square and we put the value of a square as 4c square, we get this equation, and from here we reach b square is equal to 2c square. So now this is all very similar to the equation 2b square is equal to a square. So let's see what we can infer from this equation. This means that 2 divides b square and so 2 divides b. Again using theorem number 1.3 with p is equal to 2. So now from the equation b square is equal to 2c square, we can infer that 2 divides b square. So 2 divides b, and from theorem number 1.3 which states that let p be a prime number, if p divides a square then p divides a where a is a positive integer. So here the prime number is 2 and it divides b square, hence it is going to divide b also. Therefore a and b have at least 2 as a common factor. Now since a is also divisible by 2 and b is also divisible by 2, 2 becomes one of the common factors of both of these numbers. But this is contradictory to the fact that a and b have no common factors other than 1. So when we earlier discussed that A and B are co-prime, but now we are getting that 2 is a common factor. So this is a contradiction. This contradiction has arisen because of our incorrect assumption that root 2 is rational. So basically, why a contradiction arrives is because the assumption that we considered initially is wrong, which was that root 2 is a rational number. So we conclude that root 2 is irrational. This was a very interesting proof. So now, because the result which we got is not correct, this implies that our assumption was incorrect. So the correct thing to assume was that root 2 is an irrational number. So I hope that I have made this proof very clear to you, and we are going to take a look at some tips which are going to help you in proving other theorems as well. Always use pen and paper to prove theorems. To basically prove and solve theorems, you should use pen and paper because it is the best method to do so. Mention all the theorems that you are using. So while proving this theorem, we used theorem number 1.3 and we had to mention it everywhere. So this is a very important step. Don't skip any steps. Steps are very essential, hence write all the steps and don't forget to write the theorems. So I hope that I have made this proof very clear, and thank you for watching.